Today it counts 30% of the overall grade for the Ulster program people. For those who make mini projects, it's actually just relevant for that people. Sorry for the other one to hear about that, that you are bothered with this. The delivery will be the COMSOL model, which is a version of the one you researched in the application lab. 6 to 8 pages. And I would like to ask you for the paper to use a template to have it comparable. Maybe I don't explain all that points in detail again today. You will find this slide in an updated version, not yet, but this one later in Moodle, so you can read through this. If you have questions regarding the proceeding, feel free to ask me. One thing I addressed already yesterday, because I'm aware it's more convenient, more comfortable to have a COMSOL license on your computers, particularly if you work on the project. So I committed to organize a test license, and we should come up with an idea in which period. So my suggestion would be something like from 1st of May to 20th of May or 22nd of May. That is when the lectures officially stop, to provide you with such a test license. Yesterday I already explained it's an issue to get it for a longer period. For 2 weeks is not a problem, but this is already much more than 2 weeks, that period. So otherwise I would provide you for 8 years, but that's not so easy possible. If this test license finishes, then you still, of course, can continue do your project work within the lab here, the computer lab, but it's not so easy. So from my point of view, it should be easy possible to finish it within that time frame. So you finished, that might be another advantage, so you are done with it. Some people ask me explicitly, because they want to go back to Northern Ireland, what happens if I'm not here, so that would fit. If you want to take more time for it, no problem, but then you stick to the licenses provided on the computer. Any comment on that? Any suggestion? I mean, what I could do, I could make the whole period later. I'm not sure if this is a good idea, because you get more and more busy. So it's a question of preference when you want to do this, and put it more in the future sounds promising, but it's usually. But it's something. Maybe just to get an idea, who would like to have it that I organize it for an early period? Because you are ready now, you can do the project. There will not be much more things you can get from the lecture here to do the project. So there's no reason not to start, that's the point. And so like one option would be to have the period within the lecture. Who would prefer this? Maybe you can give a hand sign. That's our, in the later period afterwards, nobody, then I think we came up with a decision, a procedure. And as I said, you're not, if by chance you say you want to work later, you can do it. It's just not so comfortable. Another thing I already addressed yesterday, I organized an appointment in a lab, some floors up. The idea is to make some experimental work, or actually the lab guy is doing it for us, a tensile testing. And I learned yesterday, probably most of you have done this type of measurement already, so anyway we do it again. And what we get from there is data, stress over strain, some diagram. And from that data, we like to extract that parameters here. So some parameter definitely used in the Hookean region, but interesting for us in that case also in the nonlinear region. The reason to extract that parameters is that in the next step we will do a modeling, advanced modeling of plastic deformation. So for that we need to have parameters which we feed into the model. So this is like the first step to do this. The date I arranged already on 7th of May is a Thursday, and the lab is not crazy large, so the guy who's operating it suggested to have 10 people maximum. So I will organize to fit in all of you into slots of 10 people. So that's something I have to organize somewhere next time, and then I will communicate the according time slots for you. Probably I make some Moodle, doodle or something. No, maybe not doodle. So I will think about how to offer you something you can sign for it, and then we fill up the persons. Another last comment about this, because I did it yesterday, I also want to share with everybody else, maybe missing yesterday. It's not settled, but I have some ideas about the final examination which might be related to that topic. So that is like a preparation for it. So I strongly recommend to be there in the lab just to see everything, and also afterwards not missing the part where we're modeling the thing. Yeah. Any question to this? Some recommendations, comments, whatever? No? Then we just continue. You saw several times already. I don't repeat what is written here. We were dealing with some backgrounds, and finally we were discussing about mechanics, solid mechanics. Let's switch to the content. I introduced in a quick way the various structural mechanic interfaces, single physics, multiphysics. Yes?
Sorry, quick question on the project. When exactly is that due for, like the whole project?
The final delivery date. Yeah, this is something we can decide together in a way, but that will not be at the end of the lecture period, so it will be later.
Okay.
It should, from my point of view, reasonably be before the exam. So it also depends a little bit. Also from experience, I know if this type of work overlaps with the exam period, it's a disaster, you know, because people are already focused on that, so it's not helpful. I would recommend, if you do the project now or start now, then just submit it end of the lecture period. But for in some case, maybe you think I still want to do something, you can work late more on that. So you're not forced to deliver on 22nd of May. I think that's the last official day. We can make it a bit longer. I talked about the COMSOL physics interfaces, structural mechanics, single phase physics, and combined things like mechanics and heat and so on. I just named it, just gave an overview, and then we started talking about the fundamentals, and we did it along the possible study cases which are possible. So what you usually do first, the same thing in solid mechanics, structural mechanics, is a stationary simulation. But that was already not easy. You remember we discussed what is the basic equation, and it was something which relates a volume force to mechanical stress, and the fundamental variable, which you also can see if you set up the model with the wizard, is the displacement. So there was some discussion, where is this displacement, and finally we also ended up realizing some non-trivial concepts with the strain, how the strain is related to the displacement. I'm aware that, I'm not sure how you judge about this, but probably not completely trivial. I have not planned to review this again, we did it yesterday, but in case somebody has a question likes to address, of course I I would be very willing to clarify things. Anything left from yesterday? I should repeat. I just realized. I think I still have not the updated foils in the Moodle because I still continued working, so I didn't like to have several versions of this. Maybe I soon provide the newest version. Today we finish with this. Then I anyway have the final setup for this semester. Then you might have a look again, and if you feel that I should explain something again, then just feel free. Not next Wednesday, that's another thing I just got in mind. I'm not sure if you already realized, next Wednesday there is this ferry, Pyramid Ferry, I think they call it Pyramid Ferry. So there will be no lecture for all of you. Was not aware so far, so you can make plans for visiting the mountains or whatever, or you go to the ferry. I think that was the original intention. If you're interested about this ferry, maybe you can ask some of your German colleagues. I'm also not really sure what they do. The idea is to meet with companies, local companies, so if you're interested in that, of course, you can also use it for that. But anyway, Wednesday, no lecture, but on Thursday. We would see us again. So if you have questions, that would be an option. Stationary, and the next thing I like to talk about today, but not as deep as we did with the strain and stress and all these things, transient simulations, time-dependent simulations. Even this gives me a chance to talk a little bit about stationary, what we did last time. The governing equations looks kind of not so complicated, at least is small. This is the static situation. So what is the source of mechanical strain? That thing here stands now for mechanical strain, stress. Sorry. The source is a force. So basically, if you apply a force to some material, here it's written as a force density, it's Newton per cubic meter, but anyway, then you have inside at every point a certain phase for force, and that causes stress. I just realized now, maybe I should give a command, some comment, not a command, I also can give commands, but I want to give a comment. On that symbol. Is that the typical symbol you used for stress? Yes. The UK people nodding. What about German people? This is the conventional sign you use, that thing there. It can be confusing because that can be also used as the electrical conductivity, but so you of course see it from the context. And also, there are, at least in COMSOL, there are very different versions of stress. If you're interested, you might look up in this browsing menu, Piccola stress, and all type of definitions. So you can have also different symbols here, like T for tension. But in such situations, usually this symbol is used for stress. I think I also try to emphasize what that actually means is a balance of force. We have external forces acting on the solid, and it's counterbalanced by internal reaction, which is the stress. So if you put these forces, external forces, on the other side, that would mean sum up all relevant forces is equal to zero. It's one of the basic Newton laws. So now we want to talk about time-dependent situation. And the according equation, I think we already talked about this at the end of the last lecture, but it was very much at the end, is this one. So because we have now time involved in the logic we discussed in the very beginning about this partial differential equation, there should be terms measuring how the relevant quantity, the displacement, changes with time. So basically, time derivatives. Here we see first time derivative, second time derivative. And this is something you are familiar with also from 1D examples, like in the harmonic mass spring oscillator. That would be something like a velocity, the first derivative of some spatial coordinate, and second derivative would be the acceleration. Having this in mind, you also may remember having in mind the spring mass oscillator. In front of the acceleration, you would have a mass to describe the material property, so that is a inertia force. Here it's not mass, it's a mass density. So this is typically, you see it several times here, it's always a density quantity. And this, I think we discussed it yesterday already. This is something like a velocity, and in the oscillator equation that would be a friction force, something which damps the oscillation. So that parameter is related to some damping. So then this would be something like a spring force. Okay, I don't want to talk more about the math here. That's the same equation, just added with the parameters to give it a name. And what I want to do here with you is a demo model. So you are invited to share me building the model. Before doing this, I just put another example, which is not the one we're doing together, but maybe still interesting. What we see here is a fluid channel, and there is a like a sphere or a cylinder. Actually, it would be a cylinder in the fluid channel, and there is, I don't know how to call this, a beam or something. And if we start the fluid to be flowing, then after some time, a typical picture occurs. Van Karaman vortex streets appears. So let's see how that would look like. For some reason, it's not continue running. In the original file, it was, but here in PowerPoint, it doesn't. So it somehow creates that type of movement, flapping of that beam, and then the stream behaves as seen. That definitely is a time-dependent simulation, and for the mechanical part, which moves over time, that would be the controlling equation. The example is a bit more complicated, you probably guessed already. We have also CFD involved. I think it's not turbulent, even if it might look like turbulent, but it's still in the non-turbulent regime, so that would be something capable. But maybe the most interesting thing, it's an example of so-called fluid structure interaction. That's also something you can do with COMSOL. I just wanted to share with you that idea, because obviously the mechanical structure interacts with the fluid, and that is a certain discipline, not the most trivial one. That would be also something, you know, we're talking about mini projects. If some of you would be interested in analyzing this situation, that is an example from the lab. So you are invited. That's something I think you could do, as certain interesting aspects. Just one example, you have tons of them to be analyzed. Anyway, to do something yourself, together with me, I would suggest to continue working on that example we anyway started with, that flat bar from our measurement lab. That were this bar here, equipped with a strain gauge measurement sensor, but we don't have to worry about this at the moment. The simulation we did here was a static load, like you see here, with a mass of 1 kJ, I think it was 1 kJ, and What we want to do now is do the same thing, but for a time-dependent simulation. So I did it correct, yes. You see, this thing is moving, so we want to simulate such a situation. That we have the strain gauge at the end is not so important at the moment, but instead of static, we want to simulate that type of behavior. Before we go into the simulation, I want you to appreciate that you can see the movements of that beam. And that is some information. From that you may conclude with what frequency the whole thing is oscillating. Maybe we even discuss it now, because we anyway do this information. We have to have this information available later on. Why? Because transient simulation, I will show it you with the example in detail, basically also means that you have to tell the program you want to simulate something over time, whatever it is. Can be various things you display or you're interested in, and you have to decide for a reasonable time period. So you have no choice, you have to start simulating at 0. You cannot start simulating in the future, you have to start simulating at 0. But what is the end time? So this is something you have to provide, obviously. Maybe some ideas how we could come up with a number. Of course, you can just try out, but this can go wrong. You can get strange results if you choose the time too small. If you choose it too large, it can be also not useful. First of all, maybe to make it even more precise, the movement here we may monitor, exactly that's what we do later, by just deciding for one point, maybe in the very end of the tip, and monitoring how that moves over time. So what type of movement you would expect to get displayed when the simulation is running? Yes, like this? No. Like this. And if you would plot like the point in the very end on the tip, not like this, yeah, exactly. So something like this, yeah? That's what we are looking for. And basically that means we have to try to find a reasonable number for that time period here. If we do it wrong, if we choose too small, you would recognize probably, because you could get a result for that phase situation which may look like this. If you make very small, timing too small, then you might get the idea if you're not so much involved. You are engineers already, so you know that it's not linear with time, it cannot be. But somebody not so much involved, maybe learning, he would completely be misled. And the other option, if we choose the time to be too long, how would it look like? It would look like this, so it's also not useful. So we have to spend, if possible, some thoughts, what is a reasonable time? So how you could get an idea how long we should simulate. Any suggestions? And the answer, in a way, lies in the movie.
35 seconds?
Let's say it. 35?
3 or 5 seconds?
3 or 5 seconds. Yeah. That is not so reasonable. Wouldn't be too bad. But you know, what is the right term? Try to make an educated guess. An educated guess. The point is educated, and this is reasonable. It's not completely unreasonable, but maybe we can decide it a bit more precisely. So we would need to have an idea what we can conclude from this. I mean, 3 seconds would mean it takes 3 seconds to go up and to go down. What would you say? Is faster or slower? Faster? Yes, faster. Faster. I agree. So definitely we might say this is a lower boundary. Not completely unreasonable, but probably lower. Regarding the high frequency end, is there something we may make use of to give a limit? The point is, maybe some guy is coming up with an idea. I play it.